James Fincher. Miss Glenda James Fincher is the hardest working woman in Sickle Cell. I've known Miss Glenda for 20 years. We were in a group called Cuyahoga County Sickle Cell Affected Families 20 years ago. And then when Adrian started Kincaid's Kindred Spirits, I joined, and then I called Glenda. I said, Glenda, I found another fight we can fight with Adrian. So I would like to welcome Miss Glenda James Fincher.
Thank you, Teresa, for that introduction. She always does it to me. I just wanted to say thank you all for being here, for taking the time out of your day, your busy schedules to come out. I also wanted to say, let you know about Michelle. Another reason that we really need your help is we are also involved in legislation advocacy because we need more money toward adult treatment centers. Particularly, Ohio is very behind in that. There are many states that have adult treatment centers in each of the major cities that have been proven, research has proven, that those patients that are treated there, particularly adults, at adult sickle cell treatment centers, have better quality of life, fewer pain crises, and it costs less money. They end up having a lot less hospitalizations because they're treated instead of in an emergency room with, like she said, the stigmatization. They're treated by special doctors and nurses. They're specially trained to treat sickle cell, and they're treated promptly. Therefore, a lot of them are able to be treated and sent home. And so the cost for sickle cell last year in the United States was estimated at $1.1 billion. So it's not a new disease. Sickle cell is the most common inherited blood disorder in the world. So we now even have a World Sickle Cell Day because the UN voted that in December of 2008. So it is very important. It costs money as well as lives. And Michelle went with me last month on our second ever Sickle Cell Advocacy Day to Washington, D.C. Michelle was on a cane. She should be right now. And she went, we drove to Columbus and got a bus from there where everyone around the state went. And for someone that is as sick as Michelle is, I have my own issues. I'm 51, so I'm kind of past the average age for sickle cell. I've been through some of what she's been through. She's been through a lot more, but God has sustained me to continue doing this. But we need you all's help because when I have to take the person that's going with me is this ill and has to walk around Capitol Hill, that walk alone.
Come on.
With everybody on the bus going back, the first time we went, some of the patients ended up not being able to continue the visits to the Congress people because you are walking like crazy. And we really, that's why we need family members and friends and other people to help us. Because physically, like I said, we're sitting there with Voinovich and Sheriff Brown's healthcare assistants, and Michelle should be in hospital bed. And we really need your help. And I'm going to get right to my presentation. I just want to give you the basics about sickle cell. What is sickle cell disease? It is a term used to describe a group of inherited blood disorders, meaning that it's genetically passed. It is not caught as an infection would be. It is totally genetic. And this involves an abnormal hemoglobin, and hemoglobin is the oxygen-carrying molecule in your red blood cells. That is what causes your cells to even be red. And the sickle hemoglobin is abnormal. Normal hemoglobin designated as hemoglobin A. And there's also what's called fetal hemoglobin, which is the hemoglobin that you carry when you're a baby, in utero and soon after birth. And within 6 months after birth, your body changes over from the fetal hemoglobin, which is at very high oxygen carrying capacity, to what's called adult hemoglobin or hemoglobin A. In sickle cell, when you have the disease, you are not going to be producing very much, if any, normal hemoglobin. I have SS disease. Michelle has S beta thal. Adrian has SC disease. So there are different variants of it, and that's why I said it is a group of inherited disorders. Sickle cell is not an iron deficiency anemia. It has nothing to do with iron. It is a chronic hemolytic anemia. In other words, the red cells are destroyed very rapidly. They hemolyze, they burst. So that is what causes the anemia. And this also causes episodes of severe painful crisis, and these blockages of blood flow can cause a lot of organ damage. Sickle cell is the most common inherited blood disorder, as I said, in the world, with 10 million affected, 100 million carriers in the world. It is most prevalent in areas that tend to be endemic to malaria. That's why they believe it might have come about genetically as protection against malaria. Therefore, it's most prevalent in African areas, in the Mediterranean, and people of Indian origin. There are large numbers of sickle cell patients in not only Africa, but India, the South and Central America, the Caribbean islands, Cuba, Jamaica, also Saudi Arabia, all over the Middle East, and it is in Caucasians. It's found in Caucasians, particularly in Southern Italians and people of Greek descent. In the U.S., we have more than 80,000. The most updated numbers are putting it more like at 100,000. And it's probably undercounted because a lot of us are essentially hidden. Some of us don't have that many problems and don't even find out that they have the disease until maybe later on they might have it maybe during pregnancy or something, some kind of event that will cause a sickle cell crisis, and then they get tested. But the 80,000 number is what they're kind of averaging now, but it's really closer to 100,000, particularly with immigration of people of color. A lot of those people are not being counted. And predominantly, in this country, predominantly African Americans and Hispanic Americans, and approximately 1 in 400 to 500 African Americans, and 1 in every 1,000 to 1,400 Hispanic American births. Approximately 2 million Americans, or about 1 in 12 African Americans, has sickle cell trait, which is the carrier state. The trait is not the disease, but it means that you have one sickle cell gene. So there can be, under severe circumstances, some effects from that. But sickle cell trait does not turn into the disease. You must have 2 abnormal hemoglobin genes that have the disease. You must be born with 2 abnormal genes. In 2009, as I said before, the federal government estimated the cost for medical care in the United States, sickle cell patient, was about $1.1 billion. So this is major. When we're talking about healthcare reform, we needed it 50 years ago, when Eisenhower was the first person talking about it. Approximately 80% of that cost is for hospitalizations. Therefore, if you get the adult centers going, you can decrease that number. It's been proven. I've actually gone to a conference in Memphis in 2005 and actually got to see a panel of patients from ages 18 up to 65, and they talked about the difference across 5 years of what happened when they got an adult center, how their health improved, they had fewer hospitalizations, and so this, because we're all concerned about finances, this automatically would be a cost savings to get these adult centers funded. And the type of hemoglobin a person has, as I said before, is determined by 2 genes, 1 gene from each parent. Someone with 1 normal gene and 1 sickle gene is what is called the heterozygous state, and they are a carrier sickle cell. That is the trait, not the disease. This is called the trait, and the gene, that abnormal gene they have, just like the normal gene, can be passed on to their offspring. Someone inherits 1 sickle gene from each parent. That's the homozygous state. Therefore, you have an SS. Then you will have sickle cell disease. The other abnormal hemoglobins I mentioned, because there are actually hundreds of them, but the most common ones are sickle, thalassemia, and there are different variants of beta thalassemia also, and the sickle C gene. As I said, Adrian has SC, Michelle has S beta thal, we have someone else here also that will be speaking, and I have SS. This is a diagram basically showing you what I just explained. Parents, both in this situation, such as my parents, both have the trait. They had no idea about sickle cell in 1959 when I was born, but what happened is with each pregnancy, the odds are the same. So with each pregnancy, there was a 25% chance that the child would have the disease, 50% chance that the child would be a carrier, and a 25% chance that the child will have totally normal hemoglobin.